AB Calculus Note Card 29, Natural Logarithmic Function. This is the 29th video lesson in the series inspired by Stacy McMullen, formerly the Dallas Independent School District, who developed this Note Card curriculum. Natural Logarithmic Function, and that's going to be g of x equals ln, or natural logarithm of x. And for g equals ln x, the inverse of this function is going to be e to the x, or like this. Okay, that's going to be the inverse I'm drawing in blue. Ln x, g equals ln x, is continuous and increasing everywhere. And when you're increasing or decreasing everywhere, we call that a monotonic function. The limit as x approaches negative infinity, as you can see, we have a vertical asymptote along the y-axis, so we never approach infinity, negative infinity. So we have that as x approaches infinity, g of x equals infinity. Things are helpful to know. Ln of 1, or natural logarithm of 1, equals 0. So what that means is that e to the power of 0 is equal to 1. And then if you have e to the power of ln x, it's like the e and the power of natural logarithm cancel each other, and we have x. And finally, for the derivative, basically what you have is, if you have the derivative of the natural logarithm of u, it's going to be du over u. So we can call this derivative over the original. It's just another way of saying the same thing. Okay, let's go work out some problems. I think we have 6 of them here. Find v prime of t for v of t equals ln of t squared plus 3. And so our derivative, d dx, of this t squared plus 3 is going to be simply 2t. So v prime of t is going to be equal to the derivative of the original over the original t squared plus 3. And I don't think we can simplify this any further, so that's problem 1. Problem 2, if y equals 4x ln 5x to the 4th power, find y prime. Well, we have here the product of two functions, so using the product rule graphic organizing method, I'm going to label this 4xu and this ln of 5x to the 4th power v. I'm going to come over here to the right and write our little box like we've done. I'm going to leave a little room because we have a little figuring to do on one of these, I believe. So what we have here is, I'm going to put u prime, and v prime. So u is 4x, and u prime is going to be 4. And then v is going to be ln of 5x to the 4th power, and the derivative of this ln 5x to the 4th power is going to be the derivative of the original, which is going to be 20x to the 3rd power, over the original, which is 5x to the 4th power. And this will simplify to 20 divided by 5 is 4. And then we have x cubed divided by x to the 4th power. So we have 4 over x. So that's that one. And so we're going to have uv prime, which is going to be 4x times 4 over x times vu prime. Let me just write that a little more neatly here. It's going to be u prime. There we go. Okay, so y prime is equal to 4x times 4 over x and then plus 4 ln of 5x to the fourth power. And x over x are going to cancel each other, so y prime is going to be equal to 16 plus 4 natural logarithm of 5x to the fourth power. So that's going to be our answer. Yeah, we could factor out a 4 out of this, but we'll just leave it as is. Next problem we'll look at, 3, differentiate h of x equals the natural logarithm of tangent x over 3 pi. And what I'm going to do for this one is just make a slight rewrite to avoid confusion. I'm going to bring this 1 over 3 pi out front to kind of leave this as a coefficient. And then we're going to have natural logarithm of tangent x. Okay. Well, in our trig derivative section, when you have the derivative of tangent, a helpful technique is we can write out tangent secant secant, and if we whatever we want, we can cross out. So we can, if we want the derivative of tangent, we cross out that tangent, and we have left secant secant, which is secant squared. So I'm going to work this below h prime of x. I'm going to bring this 1 over 3 pi over here, and we're going to have the derivative, which is secant squared x over tangent x. And then we can simplify from here, perhaps. Okay, secant, let me just put this out. So secant squared x equals 1 over cosine squared x, and tangent x equals sine x over cosine x. So we're just going to apply this. I'm going to continue to work down below. H prime of x equals 1 over 3 pi, and we're going to rewrite this secant squared x as 1 over cosine squared x, and this tangent x below, we're going to write that as sine x over cosine x. And what we have here is that this cosine x can cancel that squared. So what do we have left? We have h prime of x equals 1 over 3 pi, and we have 1 times 1 over cosine x sine x. And cosine x and sine x have reciprocal ratios. The reciprocal of cosine is secant, reciprocal of sine is cosecant. So we can finally simplify this down to h prime of x equals, we bring this cosine up in the numerator and call this secant x. Okay, that's secant x. And then bring the sine up in the numerator. That's going to be cosecant x over 3 pi. So we have that. That's going to be h prime of x. Next, problem 4. Find the slope of the line tangent to the graph of y equals 2 ln secant x at x equals pi over 4. Well, again, as we did in problem number 3, if we write out tangent, secant, secant, we cross out what we want to take the derivative. So we want to take the derivative of secant. We have tangent secant. So y prime is going to be equal to 2, and the derivative of ln secant x is going to be tangent x secant x over the original, which is secant x. And you should see that we have a nice little simplification here. So y prime is going to be equal to 2, secant over secant cancel each other, tangent x. And we want to plug in pi over 4. So y prime of pi over 4 is equal to 2 tangent of pi over 4. Now, I hope you have enough experience in trigonometry to realize what that is. These things, a lot of them simplify very, very much, and this is indeed the case here. Pi over 4 is right here, equidistant between the x-axis and the y-axis. So the sine cosine is going to be square root of 2 over 2, and then square root of 2 over, call it square root of 2 over 2. And so our tangent, since our tangent is sine over cosine, okay, we have sine, which is this square root of 2 over 2, over cosine, which is square root of 2 over 2, which is equal to 1. So what we have is y prime of pi over 4 equals 2 times 1, which is 2. So that's our answer to problem number 4. 5. Write an equation for a line tangent to the graph of f of x equals -2 plus natural logarithm of x squared at x equals 1. Well, to find a tangent line, we're going to need two things: a point and a slope. And our point is going to be the x-coordinate of 1, comma, the y-coordinate that we have not found, and the slope. I'm just going to write this as m sub t. So to find our y-coordinate, if we plug in 0 for x, we get -2 plus natural logarithm of 0. Okay, and what is the natural logarithm of 0? We're going to see that right up here. Remember that? Natural logarithm of I think I got something wrong here. Natural logarithm of 1. Okay, that's better. I knew something was wrong. Okay, natural logarithm of 1. Well, that's going to be 0 because what power does e need to be raised to equal 1? Well, 0. So we're going to get -2. So now we need to have the slope of our m sub t. So f prime of x is going to be derivative of -2, which is 0. And so we're going to have the derivative of x squared, which is 2x, over the original, which is x squared. And that x and squared are going to cancel each other, so we're going to have 2 over x. So f prime of 1 is going to be equal to 2 over 1, which equals 2. And that's going to be our m sub t equals 2. And so 1 is going to be our x1, -2 is going to be our y1, So we can write our equation now. Y minus y1, which is going to be minus negative 2, which is going to be y plus 2, equals 2 times x minus 1. So that's going to be our equation of that tangent line. 6, if f of x equals natural logarithm of x plus 4 plus 3 plus e to the negative 3x, then f prime of 0 is blank. Well, we want to find the derivative over the original. So we're going to find d dx of x plus 4 plus 3. I meant to say plus e to negative 3x. And that's going to be a derivative of x is 1, and the derivative of 4 is 0, and the derivative of e to the negative 3x power is going to be minus 3 e to the negative 3x. So that's going to be our derivative. So f prime of x is going to be equal to 1 minus 3e to the negative 3x over the original, which is x plus 4 plus e to the negative 3x. Okay? And then we're going to continue working below. F prime of 0 equals 1 minus 3e. If we plug in 0 for x, we have 3e to the 0 power. And then in the denominator, plugging in 0, well, if x is 0, that's just going to be nothing here. Then we have 4 plus e to the 0 power, because we plug in 0. So what we're going to get is 1 minus 3, or negative 2 over 4 plus e to the 0, which is 4 plus 1, or 5. So f prime of 0 equals negative 2/5. That's our answer. I hope this is helpful to you. Good luck, and thanks for viewing.